Okay, here we are for day whatever we are on this, no school. So our next set of notes is solving exponential equations. So to solve exponential equations, we're going to use the properties of exponents to simplify each side of the equation. Then we're going to rewrite the equation so both sides have the same base. Then once they have the same base, we're going to drop the base and then set the exponents equal to each other. So these first four examples, they already have the same base, so we don't have to worry about getting the same base. So we're just going to start with dropping the base and simplifying if we need to. So in this first one, we have one of each base already, so we don't have to simplify. We're just going to set the exponents equal to each other. So we have x plus 1 equals 9, and then we're going to solve that for x. So we're just going to subtract 1 from both sides. So we know that x equals 8. This is just a simple one to kind of show you what we do once we have the bases are the same. So for number 2, we have 5 to the 4n plus 5 equals 5 to the n minus 7. We have a base of 5, and there's 1 on each side, so we can just go ahead and set 4n plus 5 equal to n minus 7. And then we're going to solve this equation. Right? So we're going to subtract n from both sides, and then so we have 3n plus 5 equals negative 7. And then subtract 5, so that we have 3n equals negative 12, and then divide by 3. So n equals negative 4. All right. Now for number 3, on this left side of the equal sign, we have two bases. So we have to use our properties of exponents to simplify that. So because they're multiplied, we add the exponents together. So we have k plus k, which is 2k. So we have 3 to the 2k, and then there's nothing to add to the 1, so it stays plus 1, equals 3 to the 5k minus 1. So then now that we have the bases are the same, and everything is simplified, we just set these equal. So we have 2k plus 1 equals 5k minus 1. All right, so we can add the 1 and subtract the 2k. Just save some space, we'll do it all in one step. So we have 2 equals 3k, and we divide both sides by 3. So k equals 2/3. Right? So for this one, we now have to simplify on both sides because we have two bases on each side of the equal sign. So negative 4 plus 9 is 5, so we have 10 to the 5th power equals, and now over here we have to add the like terms. So v and 2v is 3v, so we have 3v, and then 4 and negative 11 is negative 7. So now we have one base on each side that is the same. We're just going to set them equal. So 5 equals 3v minus 7. We're going to add the 7. So we have 12 equals 3v, and then divide both sides by 3. So v equals 4. All right. So those are the problems when our base is already the same. And then now all the rest of the examples are if you do not have a common base and we have to find a common base. So for 5, we have 6 to the 2x minus 10 equals 36. So because 6 is the base here, we need to rewrite 36 as a power with the base of 6. So 6 to the 2x minus 10 stays, but we're going to rewrite 36 as 6 squared because it is a base of 6 and has an exponent, and that equals 36. So now that these are the same, you're going to set the exponents equal. So we have 2x minus 10 equals 2, and add a 10, so that we have 2x equals 12, and divide by 2, so x equals 6. All right, so our answer is x equals 6. All right, so for 6, we have 4 to the 3x equals 8 to the x minus 1. There is not a way that 8 can be made into a base of 4, so we have to find something that has a common base for both of them. And in this case, it is 2, so we're going to make the 4 into 2 squared, and going to put it in parentheses and then put the 3x outside of it. And we're going to make the 8 2 cubed.